Hi everyone, I'm Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Technology. Today we're going to study about Recurrent Neural Network, commonly known as RNNs. In previous classes, we learned about feed-forward neural network. Those network process information only once from the input to output. However, many real-world problems involves a sequence where previous information is important. For example, understanding a sentence, prediction, stock prices, speech recognition, weather forecasting. In such problems, the current output depend on previous input. To handle this type of data, recurrent neural network were introduced. Example, I am going to the. You automatically expect words like market, college, temple. So everyone uses previous words to predict the next word. RNN works in a similar way. And here, better understanding RNN, let's revise some fundamental concepts in the next slide. So let us quickly revise what we already know. What is a neural network? So let us, a neural network consists of interconnect neurons that learn patterns from the data, and then for feed forward neural network, it information moves one direction to another direction. No memory is maintained here. And then deep learning. Here deep learning uses multiple layers to learn a feature automatically. And here the limitations are feed forward networks cannot remember previous input. This create problems for a sequence related task. And then next slide shows the what are the objectives of a recurrent neural network. Here first point is model sequence data, time dependent data. Here RNN are specifically designed for data where order matters. Example, sentence, speech, sensor data like. And then second point refers to the, it maintains memory using hidden states. And then third point means it temporal patterns that evolve over time. And here these are the major applications of RNNs here. Here RNN are not just pattern layers, they are sequence planners. So a recurrent neural network is used to process process data, sequence data by remembering previous input to predict the future output. This is the core idea of RNN. Unlike ordinary neural network, RNN have memory. They have previous information while processing current information. Example, consider the predicting the next word, I love deep dash. So here the input is I love deep. Here the prediction comes here is learning. The prediction depends on previous inputs. Without memory, the network cannot make accurate predictions. Here past information influences future predictions. Here let us consider why ordinary neural network fail for sequential data. Imagine reading a sentence one word at a time. If you forget previous word, the sentence loses meaning. Similarly, a machine learning model without memory cannot understand sequential relationships. Example, the cat sat on the mat. If the network gets cat, later word uh, may lose contents, may lose the contents. Here the problem statement here is no memory, loss of context, and then poor sequence understanding. Here memory is the heart of sequential learning. And then ideate here to handle sequential data, we need a model that can remember previous informations like feed forward network, hidden layer, sequence data, and then recurrent networks. Here, the efficient solution is recurrent neural network. Why? Because they maintain a hidden state that act like a memory. The best solution of sequential data is a network that remembers. Here the key parameters used in RNN are input at time t. Here the current state entering the network. Example, current word is in a sentence. And then previous hidden state here. It stores memory from the previous time step. And then current hidden state, it updates memory from after processing current input. And that weight matrices are bias and activation functions. And as I already told you that there are many activation functions in deep learning like tang, sigmoid, relu, and then mostly we used relu for our predictions here. Mm. And an important formula here is hidden state is computing using current input and recurrent previous hidden state. This is how memory is maintained here. The hidden state acts like the notebook of the network. And this slide shows the architecture of RNN here. The input layer receives the sequential data, and then hidden state stores the memory, and then recurrent state for a previous hidden state to the next layer. And here two, so it is the short sequence and the long sequences here. In short sequence capture only recent informations, and it's suitable for a short sentence or a small time series here. In long sequence, it remembers information over many time steps. It is suitable for long modeling speech. Here, this shows the short memory and strong memory. Due to the short memory, there is a difficult to retain information over time. Hidden state 1 to up to the output is generated. Due to less memory, there is no retain the information, past information. But in strong memory, you have a memory to store the past information, so there is efficiently retains information from the past information. So this slide shows this what is the difference between short memory and what it's the limitations here, and what are the short memory and its benefits here. And this shows the how RNN works here. Here RNN maintains the hidden state that stores the past input as I told and so in a previous slide. What is the use of a strong memory and what are the limitations in a short memory here. This shows the architecture of RNN, how it works. And then purpose of that is application of RNN or speed convergence, learn temporal patterns, retains fast information, and is useful for a sequence data task, and it can struggle with long-term dependencies. And this shows the workflow of neural network, recurrent neural network. And these are the applications of neural network, that is a chatbot and virtual assistants, stock market predictions, medical diagnosis, video analysis, language translations. And this is the mind map of today's session. So the biggest strength of RNN is their ability to remember previous information while processing current input. Thank you. Catch you in another video.